Welcome. I am your expert technical instructor. Today, we focus heavily on the cornerstone of continuous delivery, designing a comprehensive testing strategy that encompasses local tests, unit tests, integration testing, and Azure load testing. Designing a comprehensive testing strategy is the absolute foundation of reliable continuous delivery. Without rigorous automated testing, the speed enabled by CI/CD pipelines simply becomes the speed at which you deploy catastrophic bugs into production. To architect this correctly, DevOps transformation teams must fundamentally understand the concept of the testing pyramid. The testing pyramid dictates how test types should be distributed across your development lifecycle to optimally balance execution speed with deployment confidence. At the massive base of the pyramid are local and unit tests. These must be vast in number, highly isolated, and execute in milliseconds. Moving up the pyramid, we implement integration tests that verify interactions between microservices, which are fewer in number and slower to run. At the very peak of the pyramid are UI and massive load tests, which are the most expensive and time-consuming to execute. A flawed strategy, often called the ice cream cone anti-pattern, relies heavily on slow, brittle end-to-end tests, while neglecting rapid unit tests, completely suffocating developer velocity. By designing a strategy that strictly adheres to the testing pyramid, organizations mathematically guarantee that the vast majority of software defects are caught instantly at the developer's workstation, drastically reducing the overall cost of remediation. These simple CLI commands demonstrate how developers categorize and selectively execute different tiers of the testing pyramid, allowing for rapid unit testing locally before running slower integration suites. The testing pyramid structure, placing massive volume and reliance on low-cost, lightning-fast unit tests at the base, while minimizing reliance on slow, highly expensive UI and load tests at the peak. A truly modern testing strategy is entirely predicated on the shift-left philosophy. In traditional waterfall development, testing was a distinct phase executed by a separate QA team at the very end of the release cycle, on the right side of the project timeline. This approach is catastrophic for continuous delivery, as discovering foundational architectural flaws days before release causes massive delays. Shift-left mandates moving all forms of validation, including unit testing, security scanning, and code quality linting, as far to the left of the timeline as mechanically possible, directly onto the developer's local workstation. By executing local tests via pre-commit Git hooks, developers are instantly notified of defects the second they write the code. This immediate feedback loop empowers developer responsibility for code quality and spectacularly reduces the mean time to resolution, MTTR. When a bug is caught locally, fixing it costs virtually nothing. When that exact same bug escapes into a production environment, the cost of remediation, including emergency triage, pipeline execution, and potential customer data corruption, increases exponentially. Shift-left is not merely a technical configuration, it is a profound cultural transformation. This configuration utilizes Husky to enforce the shift-left philosophy locally, automatically intercepting the commit process to execute linters and unit tests, physically preventing broken code from leaving the developer's machine. The shift-left timeline, pushing massive testing responsibilities leftward to the local developer and CI pipeline stages, preventing the costly propagation of defects into downstream staging and production. The base of our strategy begins with mastering the developer inner loop, the highly iterative process of writing code, running local tests, and committing. Unit tests are the absolute core of this loop. A unit test evaluates the smallest testable part of an application, such as a single function, in complete isolation. To achieve this profound isolation, developers must heavily utilize mocking frameworks to simulate external dependencies like databases or third-party web APIs. If a test relies on a live network connection, it is an integration test, not a unit test. When designing this phase, DevOps architects must implement aggressive code coverage thresholds. By configuring Azure pipelines to automatically analyze the unit test execution, you can establish a rigid quality gate that completely fails any pull request that drops overall code coverage below a defined mathematical threshold, such as 85%. This strict enforcement guarantees that as the application scales, the testing safety net scales proportionally with it, ensuring that no new business logic enters the main branch without verifiable, automated testing proof. This pipeline task executes the suite of unit tests while simultaneously capturing detailed code coverage metrics, providing the necessary mathematical data to enforce branch quality gates. The developer inner loop, writing code and executing isolated unit tests locally. If tests fail or coverage drops, the developer loops back. Absolute success allows pushing to the CI pipeline. Once code is successfully committed and merges into the CI pipeline, we transition to the outer loop. This is where we design and implement robust integration testing. While unit tests prove that a function works in perfect isolation, integration tests prove that the various modules, APIs, and microservices communicate flawlessly with one another. Unlike unit tests, integration tests require real, live dependencies. This introduces significant pipeline complexity. To execute highly reliable automated integration tests, DevOps teams leverage containerization technologies like Docker to dynamically spin up ephemeral, fully populated database instances directly within the Azure Pipeline agent. The application code connects to these temporary databases, executes complex transactional tests, and asserts the correct data mutations. Once the integration suite completes, the pipeline automatically tears down the ephemeral containers, ensuring a pristine testing environment for the next execution. This automated provisioning guarantees that your integration tests do not suffer from data collision or state contamination, providing exceptionally high confidence in the architectural integrity of the application. This YAML snippet demonstrates pipeline services architecture, dynamically provisioning an ephemeral Redis container alongside the build agent, exclusively to facilitate live, stateful integration testing. The automated integration testing flow. The pipeline dynamically spins up an ephemeral database, executes the stateful test suite, tears down the infrastructure, and formally reports the results. Moving higher up the testing pyramid, we encounter functional UI and end-to-end E2E testing. These tests completely simulate the actual user journey, physically driving a web browser to click buttons, fill out forms, and validate screen rendering. Designing an E2E testing strategy typically involves integrating robust automation frameworks like Selenium or Microsoft Playwright directly into your release pipelines. While incredibly valuable for verifying the complete, integrated stack, E2E tests are notoriously slow and highly susceptible to flakiness, meaning they occasionally fail due to network latency or slow browser rendering, rather than an actual code defect. To manage this, a comprehensive strategy must restrict the volume of E2E tests to only the most critical, revenue-generating user paths, such as the checkout process. Furthermore, you must explicitly configure your pipeline to automatically quarantine and report flaky tests. If a test passes and fails intermittently without code changes, it destroys team confidence in the deployment pipeline. Actively querying and refactoring flaky UI tests is a mandatory maintenance requirement for sustaining continuous delivery velocity. This VS test pipeline configuration targets the compiled UI tests and crucially enables the rerun failed tests parameter, providing immediate tactical mitigation against intermittent browser flakiness. The E2E testing lifecycle, deploying to staging, launching a headless browser to execute the user journey, and rigorously evaluating result stability to identify and flag intermittent, flaky tests for refactoring. The final major pillar of a comprehensive testing strategy is performance and stress validation. Functional correctness means nothing if the application instantly crashes under peak user traffic. By deeply exploring Azure load testing, DevOps engineers can seamlessly simulate massive, highly concurrent global user traffic directly against their staging environments. Azure load testing allows you to define complex JMeter scripts that mimic thousands of users simultaneously logging in, querying APIs, and executing transactions. The strategic goal here is to identify performance bottlenecks, precisely measure maximum transaction throughput, and determine the exact point of resource saturation. By executing load tests within the release pipeline as a formal quality gate, you mathematically guarantee that any new code modification has not inadvertently degraded the application's response latency or broken its horizontal autoscaling configurations. This is absolutely critical for enterprise applications preparing for major launch events or highly anticipated marketing campaigns where traffic spikes are guaranteed. This specialized pipeline task seamlessly triggers an intensive Azure load test utilizing a predefined configuration file, bombarding the staging environment to extract critical stress telemetry. The load testing protocol. Once staging is ready, the pipeline triggers the load test, injecting massive traffic to analyze resource saturation, automatically failing the release if performance is degraded. To conclude this comprehensive module on designing a testing strategy, it is critical to recognize that automated testing is the foundational pillar of continuous delivery. By implementing rigorous local tests, automated unit tests, extensive integration validations, and cloud-scale Azure load testing, your transformation teams guarantee that only the highest quality code reaches your production environments. This multi-layered approach to quality assurance drastically reduces deployment risk, enhances system reliability, and ultimately delivers superior value to your end users. We have deeply explored the shift-left philosophy, recognizing that identifying defects early in the development lifecycle exponentially reduces the cost and complexity of remediation. Furthermore, integrating these testing methodologies directly into your Azure DevOps CI/CD pipelines ensures that quality gates are enforced autonomously, establishing a highly secure and compliant release process. Cultivating this culture of automated testing empowers developers to refactor with absolute confidence and deploy with unprecedented frequency. Please remember to like this video, subscribe to our technical channel, and visit quicktechie.com for premium Azure certification preparation. At quicktechie.com, you will find extensive Q&A banks, brilliantly structured ebooks, immersive audiobooks, interactive training modules, and expert interview guides specifically designed to accelerate your DevOps architecture career. Thank you for joining me, and I look forward to exploring more advanced deployment configurations in our next technical deep dive. Extending the testing strategy into production, this CLI command configures continuous global availability ping tests, ensuring the application remains highly responsive long after the initial deployment. The ultimate quality continuum, beginning with shift-left unit tests, progressing through robust integration, E2E, and load testing, and culminating in relentless, continuous production monitoring.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.